Hello students, in this video we are going to see the solutions of ordinary differential equations by using Laplace transform method. So the main use of the Laplace transform, any transform, is to solve the ordinary differential equations. Okay, using Laplace transform we can solve. So we have seen a basic method, that is yc plus yp, that is complementary function plus particular integral. But we do a different form. Okay, so consider a linear differential equation of order n with only constant coefficients we can solve. Okay, variable coefficients it's not possible. Okay, dny by dt power n. There we have seen dx power n, but the dependent variable is y, independent variable is t. So we take like this. Okay, the coefficient of second n minus 2 derivative, n minus 1 derivative is a1, dn minus 1 y by dt power n minus 1, and a2 and ans and dn dy by dt and an into y is equal to f of t. This is a general form of ordinary differential equation. Okay, this dny by dt power n can be written in the short form as yn, that is nth derivative of y with respect to t. So this one also a1 into y n minus 1, n minus 2, and so on up to y dash y. A and y is equal to f of t. Okay. So where f of t is a function of independent variable, the right hand side can be any form. Okay. So they will give you the initial conditions also. What is the initial conditions? Y of 0 is equal to some value, and y dash of 0 is some value, y double dash, and so on up to, if it is the order is n, we get n minus 1 conditions. So that is, if the order is 3, we get only 2 conditions. If order is 4, we get 3 conditions, n minus 1 conditions. The initial these are called initial conditions. Okay. And next, let us see the working rule. What is the working rule? Let us see. Okay. Now, first we apply Laplace transform on both sides. So the equation is like this: yn plus a1 into yn minus 1 plus and so on plus an minus 1 y dash plus an y is equals to f of t. Now first we apply Laplace transform on both sides. Laplace transform on both sides. Now using linear property, what do you write? L of yn plus, using linear property. So a1 outside, L of yn minus 1 plus and so on plus an minus 1 into L of y dash plus an into L of y, and here this is nothing but f bar of s. So that is L of Laplace transform of f of t is f bar of s. We will get it. And here there are some formula, Laplace transform of derivative formula. Here we apply. What is the Laplace transform of derivative formula? L of y dash. So L of y we keep it as is. L of y we keep it as is. And here L of y dash we substitute some value. That is what the Laplace transform of derivative. So in the first part of this unit, that is Laplace transform topic, we have seen Laplace transform of derivative. I told you in the topic also. This will be useful in the last topic, the application topic. I told you like this. Now here L of y dash is nothing but s into L, y bar of s, or L of y of t also we can write. L of y of t is nothing but y bar of s minus y of 0. Y double dash of t is s square y of s into y of 0 minus y dash of 0. Say here only the first term is positive, remaining all are negatives. The power s is start with first derivative start with s, second derivative start with s square, nth derivative start with s power n minus 1, n minus 2, and so on up to s power 0, that is 1. So s square, s power 0, like this up to s power 0. And next, only first term we get y bar of s, or L of y of t also we can write. Y bar of s is nothing but L of y of t. So last we get this one, L of y is nothing but y bar of s. Also we can write. Okay. Next, here s power n. So that is the second term onwards, y of 0, y dash of 0, y double dash of 0, like this. Y of 0, y double dash, y dash of 0, y double dash up to n minus 1. So here, first derivative n, 1 minus 1, 0 derivative. 2, 2 minus 1, 1 derivative. If it is triple derivative, up to second derivative. So these are the formulae. We have to substitute here. After applying Laplace transform, after applying linear property, we substitute here. After substituting, so this is I'll explain here. Now, after substituting, keep only L of y to on the left hand side, L of y or y bar of s, whatever. Y bar of s or L of y both are same. Remaining everything on the right hand side. So we get some function of s, f bar of s, and joined with some ss here left. Okay, f bar, and take L to the right hand side. So what do you get? L inverse of f bar of s. Till now we have applied only Laplace transform. Now here inverse Laplace. The right hand side apply inverse Laplace transform. The solution is the answer. So here one particular thing. So this may be somewhat confusion. By seeing first problem, you will get the confusion will be removed. And here any ODE. So after doing first, we do what? We find general solution, isn't it? First we find general solution and substitute the initial condition. So here initial conditions also given now. So y of 0, y dash of 0, something like this. Y of 0, y dash of 0. Substituting initial values, we get here we get arbitrary constants. So we can find the arbitrary constants values, we get particular solution. So generally, after solving ODE, we get general solution. From the general, you applying the initial properties, we get particular solutions. But using this method, Laplace transform method, without need of general solution, directly we find the particular solutions. We get directly particular solution. Okay. Let us see first problem so that you can easily understand by seeing the problem, the solution. Okay. So they definitely ask you using Laplace transform. Whenever they ask you using Laplace transform, apply Laplace transform. Otherwise, we can do the normal method, that is yc plus yp method. We can apply. We take auxiliary equations. That method we have already known. Okay, so let us apply Laplace transform. So this is the question, and this question, first of all, given that so now since it is a second derivative, so we get up to y dash. That is two conditions. Okay, and d square we can write it as y double dash. 4 into d we write it as 4y dash, and 5y is equals to 5. We get like so. We have to write in the form of y's and y dash, y double dash. Now, what's the first step in this method? Apply Laplace transform on both sides. Left L of this one and L of 5. Okay. Left side using the linear property L of y double dash, 4 outside, L of y dash, 5 outside, L of y is equals to L of k. What is Laplace transform of k? K by s. Like this, L of 5 is 5 by s. So right hand side keep as is. The left hand side, L of y double dash, L of y dash. These two formulae we have seen here. Apply these two, substitute these two. Substituting these two, first L of y double dash is nothing but s square L, y bar of s or L of y, both are same. I told you. Here it is y bar of s. But in the place of y bar s, we can also write L of y. I told you now. So L of y double dash is nothing but s square L of y minus s into y of 0 minus y dash. This is direct formula. And y dash, y, L of y dash, L of 4 into L of y dash is, this is direct formula again. S into y bar of s we have seen in the formula. In the place of y bar s, we can also write L of y of 0. This is as is, the remaining terms as is. Now, here we substitute y of 0. What is y of 0 value? Here it is given. Y of 0 is 0, y dash of 0 is also 0. Substitute those things. The second step, we substitute it. Okay. Y of 0 is 0, y dash of is also 0. And here y of 0, 4 into 0. So here we take L of y coefficients. What's L of y coefficient? S square plus 4s plus 5. So s square plus 4s plus 5. Remaining all are zeros if you observe. If they are not 0, they may be a function of s. So we take it to right hand side directly. So otherwise we get like, so the right hand side is as is up to this step. Okay. Next step. But I told you the process, first keep only L of y left hand side, remaining all to right hand side. Remaining all to right hand side means take s square plus 4s plus 5 also right hand side. So actually 5 by s is only in the right hand side. So 1 by s square plus 4s plus 5 we get. Okay. L of I. And after getting this form, what do we do? Take L to right hand side. Take L to right hand side, we get L of y is nothing but y of t. Y is same as y of t. Okay. And next y of t is equal to 1 second. Here. Y of t is L inverse of this one, right hand side. Take L y of t on the right L to the right hand side, we get L inverse. So L inverse of what? We get this one. L inverse of this one. Here we can apply partial fraction or convolution theorem. Any one of them we can apply. Here I'm explaining partial fraction, so you can apply. You can also apply convolution theorem. Now, first we shall see the partial fraction method. A by s, bs plus c by s square plus 4s plus 5. Using the partial fraction, we get a value is 1, b value minus 1, c value minus 4. Substitute all these things. A by s, that is 1 by s. Bs, what is b value? Minus 1s. Plus c, c is minus 4 by s square plus 4. Okay. Like this, we get the partial fraction. Okay. And this minus, taking minus outside, s plus 4 by s square plus 4s plus 5. And we apply inverse Laplace transform. L inverse of 1 by s is 1. L inverse of s plus 4 by s square plus 4s plus 5. Here we apply first shifting theorem. What is first shifting theorem? The middle one, 4s divided by 2s. What do you get? 2. So s plus 2 whole square. First we write the denominator, s plus 2 whole square. And 5 minus 2 square. That is 5 minus 4 is 1. First we write the denominator and the numerator. The numerator first write whatever we got here, s plus 2, right here s plus 2. And what we have actually s plus 4. So s plus 2 already we have written plus 2. Now here we apply the first shifting theorem. Using the first shifting theorem, s plus 2, we change s plus 2 to s. That is s plus 2 is s plus 2. And s plus 2 whole square becomes s square plus 2. And e power at. What is a here? S minus a. A's value is minus 2. So we get e power minus 2 into this. Okay. Here again apply linear property, s by s square plus 1 separately and 2 by s square plus 1 separate. What is L inverse of s by s square plus 1? Cos t. Direct formula. 2 by s square plus 1. 2 we can take it outside. 1 by s square plus 1 is sin. The final answer is 1 minus e power minus 2t cos t plus 2 sin t. So this is the final answer. We got directly the particular solution, not the general solution. No need of the general solution. We get the particular solution. Here we have seen the partial fraction. Now here I will apply convolution theorem. So that convolution theorem is can also be practiced. Okay. Here I can write. So in this notes, it is partial fraction method. I'll do convolution theorem. Okay. Here I'll take f bar of s as 1 by s square plus 4s plus 5. G bar of s as 5 by s. Because we have to take g bar of s as simple as possible, I told you. And this, the remaining, I'll have taken as f bar of s. So we find L inverse of 1 by s square plus 4s plus 5, which can be written as L inverse of, first we write the denominator. What's the denominator? 4s divided by 2s. S is cancelled, 2 2's. So we write s plus 2 whole square. S plus 2 whole square. Here 5 minus 2 square. That is 4. That is 1 plus 1. We get like this. Okay. And here in this case, L inverse of this one. Numerator as is 1. There is no s function of s here. Okay. Next, change s plus 2 to s and e power at. What is a? Minus 2 here. So e power 2t, L inverse of 1 by s square plus 1. What is 1 by s square plus 1? Sin t. E power minus 2t sin t Here, what is g of t? L inverse of phi by s. What is L inverse of phi by s? Phi. L inverse of k by s, k. This is f of t and this is g of t. G of t is this one. Sorry, this is reverse. This is g of t. This is f of t. Okay. Using convolution theorem, L inverse of phi by s square plus 4s plus phi into s. I'm writing s at the end so that using convolution theorem, integral 0 to t f of u. What is f of t? E power minus 2t sine t. In the place of t, put u. So what do you get? E power minus 2t. E power minus 2u. Sine t. Sine t is nothing but sine u. Du. Okay. And f of u, g of t minus u. What is g of t minus u? Nothing but phi. So that's why I take g of t as simple as possible. So we get g of t minus u is nothing but phi. Multiply by phi du. So the answer is, so here phi I am taking outside. Integral 0 to t e power minus 2u sine u du. Now we have a formula, integral e power at sine bt. Here I'll write 1 second. Integral e power at sine bt formula. dt or du, whatever. Okay. E power at by a square plus b square into a sine bt minus b cos bt. Okay. Using this formula, herein is nothing but e power at. What is a value? Minus 2. B. What is b? Nothing but 1. Sine bt. B is nothing but 1. Substitute those things. E power at. What is a? Minus 2t to u. Here in this case u. By a square, that is minus 2 square plus b square minus 1 square plus 1 square. Okay. Next, a sine bt. A is nothing but minus 2 sine bu minus b. B is nothing but 1 cos bu. In the place of t, u. So this is from 0 to t. Okay. Now here in the place of u, first upper limit t. E power minus 2t by phi. What is phi? Here phi is also there. I've forgotten this one. Phi also there. Next, minus 2 whole square is 5. 4. Minus 2 whole square is 4. Plus 1 is 5. So we get 5 into e power minus 2t by 5. And next here minus 2 bt. Minus 2 sine bt. Sine bt minus cos bt. Cos bt. This is upper limit. Minus lower limit. Again 5 into e power 0 by 5. Isn't it? In the place of u, put 0. Sine 0, cos 0. Minus 2 sine 0. Minus 2 sine 0. Minus cos 0. This is lower limit. Okay. Here 5 gets cancelled. Here also 5 gets cancelled. So e power minus 2t. Nothing in the denominator. Minus 2 sine bt. So minus we can take it outside. So we get plus here minus. Plus cos bt. minus sine 0 is 0, cos 0 is 1, minus into minus plus 1. This is the final answer. So I'll write 1 first. 1 minus e power minus 2t, 2 sin bt plus cos bt. Like this, we have practiced convolution theorem problem also. Here, see the what's the answer after doing the completely a bigger partial fraction takes much time. We get the same answer 1 minus e power minus 2t, 2 sin bt plus cos bt, 2 sin bt plus cos bt. B, in the place of b, we have to substitute 1. Forgotten. So here in the place of b, we substitute 1. B value is 1 now. In the place of b, 1. So we get sin t, 1 minus e power minus 2t, 2 sin t plus cos t. So we got the same answer. So you choose which one is easy. Partial fraction method easy or convolution theorem is easy. You do the thing. Okay, this is the way we solve the ordinary differential equations. Now let us see the next problem. Using Laplace transform method, d square plus 1 y is equal to 6 cos 2t. The conditions y of 0 is 3, y dash of 0 is 1 when t is equal to 0, like okay. And d square we write it as y double dash 1 into y is 1 by 6 cos 2t. Now first step, what is the first step? Apply Laplace transform. L of y double dash plus y plus L of 6 cos 2t. Okay. Now using the linear property, L of y double dash, L of y separately. And what is 6 into 6 common? Cos 2t Laplace transform is s by s square plus a square. That is a square is 4. 2 square is 4. Okay. And next is, what is L of y double dash? Using the formula we have seen s square L of y minus s into f of y of 0 minus y dash of 0. L of y as is and 6s by s square plus 4 as is. Now here we substitute y of 0, y dash of 0. What is y of 0? 3. Y dash of 0, 1. Substitute those things. This is 3s minus 1. Okay. And we take L of y common. What is L of y common? S square plus 1. The remaining minus 3s minus 1, I'm taking right hand side. 1 plus 3s. Okay. And I told you the method, we keep L of y only in the left hand side, remaining all to right hand side. S square plus 1 also the right hand. 6s by s square plus 4 into s square plus 1. And 3s by s square plus 1. 1 by s square plus 1. So s square plus 1 I have taken right side. Now we have to find the inverse Laplace transform on the right hand side. Here we can apply partial fraction as well as the what you call convolution theorem. Okay. Here partial fraction is easy. I told you the shortcut of this one. Here in this problem, partial fraction is easy. So 6s by s square plus 1, s square plus 4. I told you the shortcut form 1 by 4 minus 1, bigger minus smaller, into numerator is as is whatever we have a 6s by s square plus smaller one minus 6s by s square plus bigger one. This 1 by 4 minus 3 is I'll take the 6 outside. This 6 outside I'm taking. And 4 minus 1 is 3 into s by s square plus 1 minus s by s square plus 4. This 3 ones, 3 twos. So after partial fraction, here the method is completely a bigger one. We get the same answer. See here we can see. See here. What do you get? 2s by s square plus 2s by s square plus 1 and minus 2s by s square plus 4. Minus 2s by s. Same thing we get it. This is the shortcut method. In exam also you can use shortcut method. Okay. And now here we find the inverse Laplace transform of this one. Okay. Only this is first term. This is first term. The remaining terms we can use as is 3 as is L inverse of s by s square plus 1 is cos t direct formula. 1 by s square plus 1 is sin t direct formula. This we have to do. Okay. And after partial fractions, we get this one. And here also, 2 outside, s by s square plus 1 is cos t. And minus 2 outside, s by s square plus 4 is cos 2t. 2 into cos t minus 2 cos 2t plus 3 cos t plus sin t. So we get, so 2 cos t plus 3 cos t is 5 cos t minus 2 cos 2t and sin t as it is. So minus 5 cos t minus 2 cos 2t plus sin t. So this is the final answer, particular solution directly. Okay. And let us see the last problem in this topic. This is the last problem. Third one. Using Laplace transform, solve d square x by dt square plus 3 into dx by dt plus 2x is equals to e power minus t. D square x by, here the dependent variable is x, independent variable is t. The place of y we put x something, very simple. So what is d square x by dx square? We write it as x double dash. 3 into dx by dt we write it as x dash, and 2x is equal to e power minus t as it is. And here we apply Laplace transform on both sides. The left hand side is what you get, Laplace transform of x double dash plus 3x dash plus 2. Okay, we get like this. And the right hand side e power minus t, Laplace transform of e power minus. What is Laplace transform of e power minus t? 1 by s plus a. A is nothing but 1. So 1 by s plus 1. Here we get. Left hand side, using the linear property L of x double dash, using the direct formula, that is in every problem we have to apply this formula. Laplace transform of derivative. S square into L of, we have used y there. Here L of x. X is same as x of t. X of t we can write, or simply we can write x minus s into x of 0 minus x dash f. This is formula. And what is that one? L of x dash. What is L of x dash? Something like L of y dash. So s into L of y, that is L of x minus x of 0. And 2 into L of x as it is. The right answer is also as it is, 1 by s plus. Okay. And here we substitute the values. X of 0, 0 is 0. And x dash of 0 is 1. X of 0 is 0. X dash of 0 is 1. X dash of 0 is 1. And 3 into x of 0 minus 3 into x of 0 is 0. This also will become 0. And we take L of x as common. So what do you get? What's the coefficients? S square plus 3s plus 2. S square plus 3s plus 2. And this term becomes 0. This term becomes 0. So we get only minus 1. Take minus 1 to right hand side, we get. So this 1 by s plus 1 is common, plus 1. And here left hand side, what is left? S square plus 3s plus 2. So first to simplify this, the right hand side. So what is the LCM? Taking LCM, the denominator is s plus 1. Numerator is 1 plus s plus 1. What is 1 plus s plus 1? S plus 2. This is LCM. And now take s square plus 3s plus 2, the right hand side. I told you the method, we keep only L of x left hand side, remaining all s terms to the right hand side. Like this we get. Now here we get the roots of this, the second term. You may be thinking that here we have to apply the first shifting theorem, or what do you call? You may be thinking that convolution theorem like this. So not required here. S square plus 3s plus 2. We have a roots s plus 1 and s plus 2. Minus 1, minus 2 we get it. So that 1 s plus 2, 1 s plus 2 will be cancelled. So what is left? 1 by s plus 1 into s plus 1. That is 1 by s plus 1 whole square. The term became simple. Now we left hand side L of x, right hand side 1 by s plus 1 whole square. Simply we got. And take L to the right hand side, we get L inverse of 1 by s plus 1 whole square. Here we apply first shifting theorem. No need of convolution theorem or partial fraction. So directly, what is first shifting theorem? Shift s plus 1 to s. 1 by s plus 1 whole square becomes 1 by s square. And e power at. Here what is a? S minus a. S minus a is s minus of minus 1. So minus 1t. L inverse of 1 by s. What is L inverse of 1 by s square? T into. So 1 by s square is nothing but t. E power minus. So t into. So x of t is equal to t into e power minus t. This is direct particular solution. Directly we get. So in this way we can solve the ordinary differential equation very easily. Once if we know the Laplace transform as well as the inverse Laplace transform formulae, we can solve this ordinary differential equations very easily using the Laplace transform method. The general method is yc plus yp, no need, no, not required. Without the need of general solution, directly we find particular solution. Okay, this is the last topic in this unit. We have completed this.